be 0 to infinity union,
You mean negative
or
infinity to,
negative infinity to
yes.
0 union.
Oh, of course, there is nothing else. There is only one restriction. Now, if I want to look at something like this, then what will be the restriction, let's say, for 33? What is the value of x that I cannot have in 33? If you ask me to plug it in, I'm going to say, sorry, I can't.
-2?
That's it. Perfect. Now, I would like to review a little bit of these exponential rules. Okay, so the exponential rules, we have a long list, but what this is all about is basically fractional exponents, which are slightly more difficult than everything else. So, in exponential rules. So, what is the issue here? We have to remember that the nth, my n has 2 bubbles, my m has 3 bubbles. So this is read the nth root of a to the mth power. The nth root of m to, of a to the mth power. But this is basically an exponential notation. The base is a, but the power is a fraction. The numerator is always the power of a. The denominator is always the index. This is, we know, is the index. So if I'm asked to, like we are here, you can choose any problem, of course. But if I'm asked, like, rewrite as an equivalent expression, and I'm asked to write 47 y to 2/3. So I'm given y to 2/3. Then I have to identify that this is the cube root of y squared. And this goes back and forth. So if I'm given a radical, any radical, I can write it as an exponential notation. If I'm given an exponential notation, but careful, with the power as a fraction only, if it's not a fraction, I can't change it into anything like that. But if I get an exponential notation and the power is an exponent, then I will change it into a radical. If I'm given any radical, I can go back and write it as an exponential notation with a fractional exponent. Now, things get a little bit more complicated if the exponent is negative. So let's work on a negative exponent. Anyone would like to choose?
$51.
51. So we have b to negative 1/3. And they say, write it as an equivalent. Fine. Well, here we have to remember one property that says a to power negative n is what? Anyone remembers? A to power negative n. What does it equal to? It's okay if you're wrong. Yes.
Is it n over a?
It's 1 over, it's a fraction, 1 over a to power same number but positive. So if I'm given a to negative 2, this is 1 over a squared. If I'm given 3 to negative 4, this is 1 over 3 to the 4th. Is this okay?
Yes.
Perfect. So therefore, I'm going to jump over all this because I'm lazy. I don't want to write it again. So first of all, I have to use this property. So I have to write 1 over b to 1/3. Then I can rewrite this how? Can anyone tell us what radical replaces this expression? Anyone, please? Can anyone tell us what radical is this?
It would be cubed b to the first power.
Exactly. The cube root of b. This is it. Excellent. Thank you. Okay. So now we're going backwards, meaning let's choose something from here and change it into an exponent. 55 to 64, anything. Anyone?
You do 59.
I was just looking at 59. This is so good. Good. So the 4th root of x to the 12th. Notice that they are already telling us, don't worry about the domain. It's secure. It's an even index, and x is positive or 0. We're safe. So when I write, I have to, because I wrote over there. So the 4th root, I have to rewrite it. Can anyone tell us how to write this radical as an exponent, or as a, I should say, an exponential notation? X to which power? Please give it a shot.
X to the 12th fourth power.
Excellent. 12 over 4. 12 over 4. But we know that this is, we can simplify it now.
X cubed.
That's it. That's why they said x is positive. Okay. Do we need another one? Or do we move on?
Can we do another one?
Okay. What about 61?
That's fine.
So it's 1 over the square root of t to the 5th. Again, t does not equal 0. And they should also say t is greater than 0. But they didn't. That's an error. That's an error. Good. So t is greater than 0. Perfect. So how will I rewrite, first of all, this as an exponent or exponential notation? Anyone, please?
Is it t to the power 5?
Power 5?
Well, I'm sorry, 5 over 1.
There is no index of 1. The lowest index is 2. And we don't write it. So it's 5 over 2. Perfect. Now I want to change this into an exponential notation. It's 1 over. What should I have here? What exponential notation is replaces 1 over t to 5 halves?
E to the negative. Oh,
Yes,
Very good.
that's it. Thank you. Okay. Real quick, do we want to look at another domain from here? Yes or no?
Yes, please.
Okay, please choose. Okay, I'll choose 73. So we have f of x equals the square root of 5x plus 4. Remember, the domain is not asking us to do anything to the function. It just asks us to find which values of x we can evaluate the function for. So what do I have to write? We had examples last time. What did we do? What did we write? Anyone would like to help, please?
Is it 5x plus 4 is greater than or equal to 0?
Brilliant. Thank you. That's all I needed. I move 4 divided by 5. How do I write the domain? This is it. That's all I need to do. I just have to present the domain and we're done.
It would be brackets 4 to the 5th, or 4 over 5.
Yes.
And, infinity.
That's it. Awesome. Final item here that I would like to review, because this will come back to us, or we will get back to it later on in the course, is something called the equilibrium point. The equilibrium point. So then we'll choose a problem from here in a minute. You choose. Okay. So the break even point deals with a profit, cost, revenue. And this is something we discussed already. We had an example. When we talk about the equilibrium point, we refer to something else. We refer to demand and supply. Here we have 3 functions: profit, cost, revenue. Here we have 2 functions to look at: demand and supply. So here is the idea for demand and supply. X is number of units produced. And here's the price per unit. Price. Good. So as we are interested in purchasing more units, the price per unit should go down. So this is an example. This is an example of the demand function. So if we purchase 1 unit, we pay this. But if we decide to purchase 20 units, we're going to pay this per unit. This will be the price per unit, this little bit. But if we want just one unit, then this, we're going to pay much more. Now, what happens when it comes to the supply? Well, the supply, the production, the corporate, if you want, this is a supply. They have a different mindset. They say, okay, so we are willing to give you more units, but at a higher price per unit. This is something called, this point right here, is this equilibrium point in which everybody is happy. In other words, for this price, we are willing to, so for this price, I'm just going to say $2, let's say, per unit, we are willing to purchase 4 units. So at this point, the equilibrium point, everyone is happy. They are willing to supply, although they are not super happy, and we are willing to purchase. So this is what we call the equilibrium point, where both functions meet. There is only one point. For the price per unit, we are willing to purchase 4 units, as an example. So we're asking these problems to determine. You'll see we come back to this type of problem later on in calculus. We are not in calculus yet. We're just reviewing right now. So I'd like us to look at any combination of demand and supply. I don't like the notation at all. I don't like the P's and the Q's. So I may have to change that a little bit to make it easier for you. But if you like it in P's and Q's, I'm fine with it. So we are only asked at this point to find the equilibrium point for each pair of demand and supply functions. That's all. Anyone would like to choose? So as you see, these are what type of functions? Look at them and tell me what type of functions are these. I was hoping that everybody will scream linear by now. So what do you think? Anyone?
78.
Right. 77, 78. What type of functions are these?
Linear.
Yeah, well, you can see the graphs also. Notice here what happens. Different situation. One is linear, but the other one is not. This is not a linear function, but this is a linear function. Again, here, this is a linear and this is a radical. So let's choose one and determine the equilibrium point. Very simple situation, still algebra, just algebra. You want to pick or I will? Okay, I'll pick 81. So in 81, we're given two functions. What type of functions are those again?
Linear.
Careful. So you understand that this is not a linear function, this is not a linear function. These are linear. So if it has x squared, this one doesn't have x squared. So this one has a, so they are, this is quadratic and this is quadratic. They're both quadratic equations. Okay, so I changed the notation so it's easier for us to understand. The demand function is this, the supply function is this. So in order to find the equilibrium point, we have to set them equal to each other. How come? Because at this point, both functions have the same y value. So we are setting them equal to each other. So x minus 3 squared equals x squared plus 2x plus 1. Can anyone square this for us?